Hello everyone, hope everyone can hear me okay, if it's come through nice and clear. Just make sure I get some Berkey music. There we go. Hello everyone and welcome to tonight's live stream. We are live, we've got chat open, and tonight we're taking on the Eqs system in Unreal Engine 4, looking at how you can use Eqs for AI. So I'm just loading up the project now, and we'll get started in a moment. Whilst we're waiting for that to start up, little housekeeping stuff. So if you want private tuition and private lessons or consultation work, I'm available for now June. May is now fully booked. There are no more slots available in May. I'm literally back to back endlessly throughout May. So if you want a session for June, email me at that link there with details of what you want to try and cover, and I'll give you estimates, availability and prices from that as well. If you want more information, you head over to my website, ryanA.com. You can find information about private consults and tuition there too. Hello everyone in chat. We can see we've got joining us tonight, we've got Deep Fried Oreo. Hello, and this I think is your first time catching this, so thank you for joining us. Hopefully you enjoy it. Zimmy Jim, hello there. Queen Atkins, Chris Burke, hello. Angus, hello again. Hello everyone watching this as well, and catch up. So the video on demand version of this, the archive of this, will be available to Patreon members immediately after the show, and will be available to everyone else 2 weeks after today. So if you want to catch up and go over this at your own pace, or if you can't stick around for the whole entire thing, you can head over to Patreon, just like for $1, and you get access to it, as well as every other video that I release there too. So let's get started, I think, and jump into Unreal. I think let's just jump in. Okay, here we are. So we've got a brand new template what we're going over today, and today we're doing Eqs system. Now if you don't know what the Eqs system is, it's basically what it stands for Environmental Query System, and it's a way for AI to query their surroundings based on certain criteria that you set it. Now we'll go over how you use it, why and when you use it, and the various options it has available to it. It's quite complex, there's quite a lot in it, so we'll go over it in there. Now on Patreon there is a brand new AI series there called Bot AI, where we're covering some of this stuff there too. So Patreon members will probably see a little bit of similar stuff they may be familiar with if they're following those videos as well. Okay, so to get started off with, we need to have a AI character to begin with. So we're just going to make a simple AI character. Go into blueprint class here. Let me just turn down the Spotify mix there a little bit. There we go. So we can make a new character, and we call this NPC. This is a very similar setup. So if you've seen any of my AI stuff before, it is pretty much the same every single time. So you make the AI controller that will control that object, and this NPC AI. We'll have the behavior tree, NPC BT for behavior tree, and finally the blackboard as well, NPC blackboard. So all this is standard. So we can set up the standard stuff you have with AI. So we can go in here and add our character mesh to this. Which is this one. Let's use the female mannequin. I don't use it enough. We'll put a female mannequin there. Rotate that around. And set it to the third person and NPP. There you go. A common mistake people make with AI, by the way, they wonder why they walk sideways. It's because they probably haven't rotated them to face X. Remember, X is always forwards. So whenever you say get forwards vector, you're usually getting the X vector of that character. So quite important. Okay, so that's that. Next we need to make it use that controller. So we go to class defaults, and you'll see AI controller class here on the right. You're going to change that to the NPC AI, so it uses the AI controller, and we are done here. We're going to go to the AI controller here, and we're going to go to the event graph and tell it to run that behavior tree to make them do that one, and that's all we have to do there. Everything else we'll leave as is. We'll just save all, and there we go. So let's now put in our Nav Mesh. So put that into my scene here, and scroll down, and I can set the box extents here. I'm going to do 4,000 by 4,000 by 1000. And that should cover the whole level. Hit P and you can see the Nav Mesh in all its glory. Okay, so if you don't know what Nav Mesh is, it's basically how the AI knows where it can and can't go. So the green means it can walk there. If it's a dark green border, it means it can't cross that border if it's not connected. So even though this surface here can walk on it, there's no way for it to reach it because there's no way to connect to it unless you add some stuff to it. But we're not worried about that today. That's not the focus today. But main thing is that's there. So let's drag our NPC into the world here, and we'll just make them run around randomly first of all. So nothing Eqs yet. We'll just make them run around randomly. So I'm going to go into my behavior tree, and we're going to make a new selector. And the selector here, we're going to do a sequence. And after this sequence, we're going to do a new task. And the new task is going to be the random point. So very simple. Again, if you've seen any of my stuff before, pretty standard stuff here. We're going to get random point in navigable radius, with the origin being the controlled pawn's location. And we're going to set a radius of, let's do 2000. So I'm going to find a random point, and we're going to set that to a blackboard key. If you don't know what anything like the blackboard or behavior tree or anything like that does, the basic AI stuff, check out my AI videos. Also did a live stream before as well talking about AI where I explain a bit more. I don't want to spend too long talking about this stuff because we've already done it before. So yeah, I don't want to lose time here instead of doing the Eqs stuff. So we're just going to do that. Blackboard key selector. Drag this out and set value as vector. So that'll send a vector over to my blackboard for another task to read it, because tasks can't talk to each other. So you need to have some way to, like an intermediary, a proxy, to intercept it. In that case, it's the blackboard. And tick success. Done that. We're going to rename it. And we call it find random point task. And we're going to put that into our sequence here. Find random point task. And, oh, I forgot to make our blackboard key here editable. So now I can see it there. And then we'll do move to here. Now we have to make that vector part of our blackboard. Go to our blackboard and we're going to go new key and choose vector. And we'll keep this as target location, which is quite important. We'll be using that for the Eqs later. So in self actor, we're going to change that to target location and move to change that to target location. So basics are set up. This character is now run around randomly around the whole map. Okay. So at the moment, she's not doing anything smart. She's just running around the whole entire map randomly based on whatever, really. So it's completely random. We're going to make it choose a point using Eqs. And this is when you want to use Eqs. If you want to use Eqs to find a arbitrary location based on dynamic data. So you don't want to say run towards player because Eqs is wasted on that. You don't want to worry about that. You can do it for that, but it's a waste of time. You might as well just do something like we just did there. It's more about the abstract. So for example, get a position that is far away from the player but also hidden, or as close to the player as possible but also hidden from the player. It could be find a location that is in front of the NPC but is also within a certain range, so on and so forth. It's dynamic in that sense. So Unreal YouTube has just asked a question: is this going to be different from my earlier Eqs tutorial from 2019? Has a lot changed in the Eqs system and framework? I don't think a lot has changed. What has changed though is I've grown and developed my better understanding of it. I've learned a lot more from it, so I can talk about what I've learned over the years and can share that with you. And there'll be occasions where I would actually I'm planning to go back to older tutorials of mine and update them or redo them completely, because myself, I'm learning all the time too. You know, I've developed my skills further and further into Unreal, become more and more proficient, especially with AI, in developing AI tools. So there may be some new stuff. I can't remember what I wrote and what I did in that one, but yeah. Anyway, so in this version of Unreal, you'll find Eqs in the artificial intelligence section here. If it's not here, it is a experimental thing that you can turn on in the project settings, okay? But for now, it is in here in the latest versions. So we're going to do an Eqs to find a hiding spot, okay? So we're going to find hiding spot. And Eqs looks like this. Now it looks very similar to the behavior tree, however it functionally is very, very different. So what we're actually going to be doing here is, first of all, we have to generate the points. Now the way Eqs works is it generates a whole grid or an array of points around the environment somewhere, and each of those points is then scored or filtered out based on the criteria. It will then pick a relevant scoring one and use that as its target location. So with our route here, you're going to drag this down here, and you'll see the generators. And these are the built-in generators. You can actually make your own. And if you have time, I'll go through and show you how to make your own generator. So here I've got actors of class, composite, current location, and points through various different shapes. Start off, we're going to go with points. Now, all these points are location-based points. So here I'm going to do a grid like so. So a grid is going to do a grid of points. And by default, it will say it will generate around the query. So whoever is calling this query, it will generate a grid around them. So the way you test Eqs out here, when you're not in game, is to use an Eqs Testing Pawn. So go to add here, blueprint class, and search classes here for a Eqs Testing Pawn. And this is the easiest way to test your Eqs whilst you're developing it. And you'll need to do that quite often because you need to make sure you're putting in the right values and it is turning out the way you want it to. So I'm going to drag this fellow out here and put him into the map. Now on the right hand side, you can scroll down and give them an Eqs template that you want to run. So I'm going to call this find hiding spot. Put that there. And there you can see the grid appear. Now this is the grid generating around the querier. Now the testing pawn is the querier. So it's generating all these points around it. And if we go look at the settings for our testing, our Eqs here, the grid half size is 500, meaning that it is 1,000 in total in width and height. The space between is 100 between each point, which I personally find is too tight. So I'll expand that a bit. So I'm going to put in 200 there. Hit save, and we should see that now it's a bit more acceptable for us. So here we have the generator doing these points here, and you can actually change the context. So you can generate the context here between item and querier. We aren't using a context item for this case. We're only doing querier for now, but I will show you how to make your own context in a second. Okay, we'll do that in a moment. So I'll generate points around the querier, and then you add points to this one. Tests to this one. So to add a test, you right click on this and you go add test. And you've got various tests here available to you. You've got distance, dot, gameplay tags, overlap, pathfinding, pathfinding batch, trace, and volume. Only some of these I use regularly. So we'll definitely cover some of them, but I doubt we have time to go through all of them. But we'll see how far we get. Next, so we're going to add distance. Okay, so I'm going to go distance first of all. And the distance here is, what it's going to do is filter and or score based on our distance from each point to the querier in this case, because by default it's to the querier. So if you go to the right hand side, if you've got it selected, you'll see the test purposes filter and score. Now you've got three options here: filter only or score only. Filter and score combines the two together. So what filter does means it will just cut out those that don't meet the criteria. So it neglect them completely. Where score will give them a score based on how appropriate they fit that criteria. And then filter and score combines them together. So we'll keep it as score only first of all. And I'll show you the other one in a second. So score only, you've got test mode, distance 3D, or you got test distance 2D or distance in the Z. So distance 3D is pretty standard. It's how far away is it in 3D space. Distance 2D, which I find is actually quite useful, because if, say, you want to test the distance between 2 points but don't want to take into account the elevation, that's quite useful. So I'm going to do distance 2D, and the distance to the query in this case. So how far is each point to the one that's calling this query. The scoring it's got clamping, scoring equation, scoring factor, normalization type, and then a preview. Now the scoring equation is linear at the start of this, meaning that it will go from 0 to 1 in a linear fashion. So if I hit save on this, then go back to here, you can see how it's scoring them. So the one closest to it is scored as 0, the one furthest away from it is scored as 1 over here, meaning that the winner of this will be this point here, so it will run to this point. But that is the scoring, and we can tweak the way it does the scoring by changing the scoring equation and scoring factors. So if I change the scoring equation here from linear to square, you get this more of a ramp up here, and you should see that reflected in their values. So hit save, and you'll see they're now lower, closer they are to the character, and the further they are, they get closer to 1. So it just changes the way it scores them. So that's square. Then you've got inverse linear. So the one closest to it will get 1, the one furthest away will get 0. Like that. And then you've also got the inverse linear, square root, which is the inverse of square, which does that. Okay. So not inverse, sort of inverse. It does it, so it's more ramped up the end, so it caps off at the end there. There we go. Okay, so we've got a couple of questions first of all. Asmund is asking, can you use Eqs for tasks-based stuff? I mean, you can do. It depends on what the task is. Remember, Eqs is all about the environment. Not worried about things like decision making, not worried about combat necessarily. You can use it combat, I guess, but it's all about environment and about movement and about placement. It's less about things that are not related to that. Okay, so and to lead into Red Chocobo's question, should you use behavior tree in Eqs for only complicated AI, or does all AI need to have these things? For example, shopkeeper, generic enemy shooter, character seeking missile, or something. So that stuff, you don't actually need AI for some things. The tools are there for your own use, and if you don't want to use them and you don't need to use them, then don't worry about using them. So the way to always think about it is use the behavior tree if you need decision making to be an easier process. You can do it without a behavior tree, but you're going to have a really headache of a time trying to get it working. So behavior trees are really, really good decision making process. So if you need to make the AI make choices based on circumstances, that's the best thing to do. Environmental queries are used if you want the character or NPC or AI to find a location that is arbitrary. So it's not a fixed point. It's not a definite point. It's based on criteria. Again, you can do it without it, but again, it's a tool for you to use. Okay, you can technically hammer a nail with your fist if you want, but it may hurt. So you use the correct tool for the job. So if you want AI to have interact with the environment, like taking down a shelf for cover, etc. So you could do stuff like that, make them run to a certain point and find that certain point. We'll go over that in a moment when we do the custom generation and or contexts. And you can see what we mean by that, and you can hopefully get the gist of it. So we'll go through it, and you can, if we take more questions at the end, because a lot of this stuff you may find answers to. So that is it by using score only. Let's go to filter. So filter will cut some out. So I'm going to change this. Well, first of all, leave it as range. So the distance is the same here, but this time filtering is going to cut out a range, and the range bit here is by distance. So the range minimum is going to be 0. The range maximum is going to be 0, which is no good because that's just going to give us nothing. Because blue means, by the way, they've been filtered out. Blue means no good. So what we have to do here is we're going to change the max value here. So the minimum I'm going to have is 0, and the maximum I'm going to have is going to do, let's do 500. Okay, now you can see it's only filtered in the ones that are closer than 500 units. Those who are further than 500 units away are now filtered out. So maybe I want to get the ones that are as close as possible to the player, to the querier, but also the furthest one away. In that case, I combine score and filter together, so I'll use filter and score. And this works the same. So you've got range here. You can do minimum, maximum, range. You can also expand these open here, and you can do data bindings. So if I want this max here to be a randomized number each time, I can go to none and do a random number. And this random number can be between two different values here. So every time it does this query, you can make it randomize whereabouts, how far away it looks. This adds a little bit more randomness to your AI, a bit more believability, so it looks less robotic. You can also bind it to a query parameter. So this is a custom parameter you can create in code. So if you want this value to change based on, say, health, for example, you can do that through this too. And you can get this and plug that in via your AI controller as well. But more on that later on. I'm going to reset that back to none. Okay, so let's put that into filter and score. So in filter and score, I'm going to make it so it wipes out the ones that are closest to the character, but keeps the ones that are furthest, and then scores those ones. So let's filter out the ones that are closest. So I'm going to go for a minimum here, and I'm going to set a minimum of 500. This will now filter out those that are closer than 500 from the querier. As you can see now, it's now scoring those that are remaining. The scoring is still going on from the center, so it's still like 0.82 in this case here, rather than 0.001, whatever. But we can go down to scoring here. And we can change the normalization type from absolute to relative to scores. If you do relative to scores, you can see now it changes it. So as soon as it starts getting them, it will score them based from those that aren't filtered. So that may be a bit better in this case. So I'm going to increase that generation here. I'm going to change that grid half size to 1,000. So a lot larger, lot larger grid. Can't speak. It's getting late. And you can see how it works here. So you can see this filtering going on here in the center, and then it scoring out like so. Perfect. Okay. So yeah. Does Eqs have good performance in game? As usual with every answer to all those sort of questions, it depends. You are just getting a load of numbers and doing lots of maths, and maths-based stuff is generally quite cheap, but it's still going to have some cost. You can actually do a profiler and see how cost effective it actually is. If you go over here, you can click on profiler, and if you click, you have to play it first of all, I guess. Hang on. Let's go simulate. I'll just play. Okay, that's doing it there, and then we'll stop. And it should show us. Should show us this. Hang on. Let's do simulate. It should do it. Maybe I have to wait for it to actually be used. Oh, it's not actually being used by anything. It's being used by Testing Pawn. Once we got onto the character, we'll see it there. So we'll come back to that. But it does tell you how many milliseconds it takes out to work out. So you can look at this profiler here. But you'll see that later when we add it to the actual character. Okay, so we've got those points there working out from the querier. Okay, but let's say we don't want it to look from the querier. Instead, we want to look at a distance from the player. Now, how do we get to do that? Well, we change the context. So on the distance here, we're going distance to querier, and this is a context. And the querier is a built-in context for you. We're going to create a whole new context, one that's going to use the player as the context. So let's go into creating that. So we go to add, blueprint class, and we're going to search for env query context blueprint base. So environment env query context blueprint base. We create that, and we'll call this one context. Oh God, hang on. Where'd it go? There it is. Context player. And we go into context. So this is how you set up a context. Now a context, it works like a normal blueprint, but you're ultimately going to need to output and register who's going to be the context for this. Now on the functions, you've got 4 overridable functions. You've got provide actor set, location set, single actor, or single location. And these are pretty standard. So if you want to provide a single actor, you do a single actor. If you want a single location, it'd be a location. Actors set, it means a group of actors, and location set is locations. So let's say you have a load of cover points. You can set up those cover points and contexts for example, or spawn points. Or if you've got like a capture the flag point, that could be here too. Whatever objective points, this is how you do it. Okay, so let's go and provide the single actor, because that's the player character. So I'm going to go provide single actor. And in here, very simply, I'm just going to right click, get player character. Plug that in. Done. That's all you got to do. So I go back to my find hiding spot. And then change that context now to our context player. Hit save and go back to here. And we should hopefully, I just realized it won't work because we're not playing. Let's change it so it works by looking at third person character. So rather than do that, I'm just going to go and get actor of class. And because get player character doesn't work if you're not playing the game. So here we're going to do just third person character, which is the pawn the player uses. If you're doing multiplayer, you can do get actors of class and get the set, and then provide actor set. Save that. I'll go back to here, save this. There you go. So now it's using this pawn there, the player's pawn, as the context. So it's filtering out those that are closest to the player, and then scoring those furthest away. But let's say we want this NPC to get as close to the player as possible while still hiding. Okay, so let's do the hiding part first of all. So let's go into our Eqs here. So with distance to query, we're going to add another test, and this one is going to be for trace. And tracing is do a line trace between each of those grid points to the context. So I'm going to do trace to and choose a trace to the player context. So our context we just made. And here I'm going to do just filter only. So I only want the ones that aren't being hit. So if I go down here, do trace data, I want to make sure I'm using the correct trace channel. Visibility, trace shape, yep, that's fine. Trace channel, we probably want to change that to camera, because I think the player pawn uses visibility to ignore. So we change it to camera. Trace shape, we'll do a line trace, that's totally fine. Obviously you can change that to any other ones you want. Trace complex, if you're using the complex collisions, not in this case, and only blocking hits, yes. And we'll do trace data. If you want to do it the other way around, so that it goes from the context to each point, you can also do that way. So you tick trace from context, and it'll trace from the player, in this case, to each of those points. Whichever way you want to do it, it's up to you. So we then go to our ball match. So ball match means true, and I think, but true means it'll filter out if it hits, I think. We'll soon find out. Yep. So if it's true, it will filter out those that are hit as true. So all these blue ones are now being filtered out because these technically can't see the player. This one can see the player because it's being hit by the female. If I told this female to move out the way, you can see how that would affect this. By the way, if it doesn't update, just move the testing pawn a little bit and it'll update for you. It will refresh it. So now we've got scoring points based on our filter going on here. Now, I want to now score those that are closest to the player. But I go to distance here. I'm going to change that to linear. Inverse linear. And we're going to hit save. So now you've got a scoring system that goes from the closest point is now scored higher. This one here is technically scoring 2, but as you can see, it's not great because it's in a weird position where it is technically getting blocked because it's going from the center of this point, getting blocked by these stairs. So what we need to do is elevate these points up a little bit. So we're going to go into the Eqs generation, and you can change the height they project up to. So I think this is what we change here. Remember rightly? So if I change that to 60, it'll raise the points up in the air. There you go. So now that one's being filtered out because it can't see that it can now see the player. Okay. Okay, cool. So we've got those ones. So now we're going to those ones. But I don't want him to go to, say, this point over here because it has to go quite far away. So I want it to also find the one that's closest to him. So I want to go to the query needs to find the point that is out of sight from the player, that is as close to the player as possible, but also as close to him as possible. So we're going to add another distance test to this one. So I'm going to right click, add test, distance. And this time I'm going to use distance to query. And the distance to query, I'm just going to use scoring. So score only. Linear should be fine. And a scoring factor of 1 should be fine, I think. We may tweak that a little bit and give that a save. So now we should see the points that are closest to the querier are now scored higher than those further away, which is not. Of course it isn't. Hang on, let's do that again. I might have to remove this bit. Oh, hello. Let's keep moving it about. Hang on. Okay, so it shouldn't be doing that. So I messed up somewhere. So we should be scoring the one closest to the querier higher. So if I increase the score factor here to like 2, it means it's going to weight it higher. So we should be looking at, oh, I should do it inverse, sorry, that's why. It's inverse linear, my bad. That's what I've done wrong. Save. There we go. So now the one that's closest to the player, to the querier, is going to be the one that's used, not the one that's furthest away. Sorry, my bad. Should have been inverse linear. There you go. We'll leave it as 2, so you can see how that working. So scoring factor means you can give it more weighting in its scoring system. I know there's questions going on. I will answer some questions in a moment. We'll get to them. Just stick it out to the end, and we'll answer those questions. Okay, so that's distance. Now you've got other ones as well. So I haven't used all of them before. But other ones I have used, for example, dot. So if you want to get like the one that's correct rotation to something, you can do that too. If you want to check for certain gameplay tags, you can get that as well. Pathfinding, if there's an actual path to those points, so you can filter out those you can't get a path to, which can be quite useful. Overlapping, I've never got to work. I don't know how. I've got to figure out that one. I don't ever use it. Volume, I don't think I've used before either. But you can get quite a lot out of this. Okay. Hit save, and we're done. Okay, so this is our now query system. Now let's get working with our NPC here. So I'm going to go to my NPC's behavior tree, and instead of finding random point in task, we're going to go here and go and get a run Eqs query. And on the Eqs query, you don't want to use the top one because it's deprecated. Sorry, not depreciated. Deprecated, which means it's not being used anymore. So it's annoying. Why they kept it there, I don't know. Just hide it. Everything you want here is an Eqs section for Eqs request. And here you can choose your Eqs query. So I'm going to run the find hiding spot. And here you can choose where you want it to store. So blackboard key, you want to store it in the target location. And what's good about this is you can do the run mode. So single best item will return the single point that is the best item that you can choose from. But let's say you want to randomize the top certain percentage. You got other options here, so you can select a random item from the best 5% options, the best 25%, or all matching or like similar ones. So if I do the single best item, it will always go to the point that is meeting that criteria. If I choose top 5%, it will randomize between the top 5% that matching points. So again, you can get more randomness and more natural behavior out of it. So that'll do there. Hit save, and now our character should run away from us and hide. If I can, oh, I'm in simulate. Whoops, I don't. There we go. So off she goes. So that was that point there. So we need to tweak those points maybe a bit higher, maybe. Why are you going now? I don't know. Okay. So why is she going up there? So I'm going to test this out. I'm going to put this over here on her position. So these points probably are going a bit too high. So what we're going to do is we're going to make that not too high, too low. So I'm going to make that higher. Change that to 100. And hit save there. Okay, now let's test that out again and see if that works any better. So where'd she go? Where are you going? So each time it reaches that point, it's now going to recalculate where it should go. So that point there is the closest one for me, was also the closest one for her. But it was also taken in account of the distance there, because it was quite close, laterally speaking. So let's have a look at the pathfinding option. I think it's this one. So we can discard, it automatically discards anything that it can't reach, first and foremost. To test purpose, we're going to do filter, and path exist. We'll do path cost. So the pathing will cost something, because it uses like simple, like normal A-star system, like the Nav Mesh always does. So it generates a Nav Mesh, and as it goes through the Nav Mesh, it gives a cost to it. So here we can actually filter out the cost. So if it costs too much to get to that point, it won't use it. So I'm going to go here and we'll do context pathfinding to querier. Path from context, yep, fine. Filter class, nothing. Filter type, we'll go for a maximum, and I'm not too sure what the cost value is here. I think it's just set as distance, so it says 1,000. I say I'm not too sure what that number meant to be, but you just tweak it until you get to it, I guess. I think it will be on filtered out now. There you go. Yeah, I think I'm filtering out too much. We can just test it on the pawn here. Yeah, see, it's only this one's going to be valuable. So we'll go into that and just change that path exist. We're going to take this up to the top as well. So it does this first. So it filters out anything with a path cost. You can also, if I turn off these ones with little tick marks, you can see how it affects each one individually. So here you go. So 1,000 is, it's done by distance. Okay. So on the pathfinding here, let's change that to have a maximum value of, say, 2,000. Okay, so you can see how the ones on top of here are now getting filtered out, even though they're actually closer in space before this one. But it's getting filtered out because it costs more to travel, because it's going up as well. So you can just tweak that number to get roughly what you want. So I'm going to go to 1,500. Okay, and that should filter out a bit more of what I don't want to happen. Yeah, okay, that looks good. Okay, let's turn on the other one. So we can turn on the other tests here. Hit save. Okay, and therefore we're now looking at a very small batch over here now. But let's hit play and see how this works. Now, if it does this, it's because it probably doesn't have a result. And you can see what it's doing underneath the hood. If you hit apostrophe key while looking at it, and then if I turn off 1 and 2 and push 3, you can see the Eqs here. If I go to F11, you can see it full screen. And divide will hide all that nonsense. So here you can see the results of the Eqs that she has. So you can see how it's scoring it, and you can test out what values are coming out as it. So you can see how she's been scored here. So at the moment you can see the Eqs test is only happening whilst well, after she moves. Okay, now if you want it to be updating all the time, which we do, we're going to go to our behavior tree and we're going to do a parallel. And what a parallel does, it means that it will do the move to, like so, but then it will loop the Eqs query whilst it's doing this. Hit save, and I think that's correct. That should work. Hit play. There we go there. There we go. So she's reached that point there. Maybe I should do an Eqs first of all. Copy that. Paste that. There we go. Okay, so she hopefully will update her Eqs in real time as I'm running around, hopefully. Oh, I've just realised I'm looking at the wrong thing. There we go. There we go, that's what I want. I was looking at the testing pawn. Okay, and where she goes. Okay. And that's the basic gist of it, really. So let's go through. The last thing I need to show you, really, is how to generate your own points, and then we can answer some questions. So a lot of this is going to be experimentation, trying to figure things out. Some examples of what I've used Eqs for is, so I made it so it generated cover points. I've done that in a new AI stuff I've been making with AI cover. I can show an example of that in a moment as well, if you want. Of it working, and I've also used it in the bot AI match game as well, which I'll show that in a second as well. But let's go for the generation of points. So to do that, you go to Blueprint class, and you go down to all classes, and you do env, and it is, I can't remember what it's called now. There you go, environment query generator. So env query generator. Click select, and we'll do custom gen. And a custom generator. So as before, we had done like a grid on the Nav Mesh. This one you could do whatever you want. So in here, you've got a generator item type, either actors or direction or point. We're gonna do points. So these are location points. Important that you change that, because if you put in the wrong one, it will crash the engine. So make sure you set that to the correct one. It does not like it if it mismatches, but nonetheless, there you go. Okay, go to functions, and we'll do item generation here. And item generation is it generating those points. Now the points we're going to generate here, we're going to first of all take the context locations we've got and promote that to a variable. And I'm just going to delete that now, and then put this in and clear the points. So each time it does it, it clears the points that we have. We're not going to keep adding points to it. We're then going to do, let's say, I don't know, let's do a line trace. Okay, so do line trace by channel. And we're going to do a line trace from the player to random points around it. Okay, we'll do surrounding points. So let's do a for loop for this. And the for loop we're going to do is going to be first to 0 to 35. So it's going to do 36 times in total. And because we're going to do a whole 360 degrees look around the place. So we're going to take this index, we're going to multiply that by a vector. Yeah. No. I can't remember now what to do. Take this and then... Hold on. We want to get, first of all, get player character. And from the player character, we're going to get their location. And that's going to be the end point. The starting point, though, is going to be the player location plus a vector. And the new location they can start at, not end at, start at, is going to be a rotational vector away. So we'll do, let's go and get, let's say, rotate vector. And we want to rotate this vector here. And we want to split the B here and rotate it by, let's make some more space here. So we're going to take the point here, and we can change X here to 1. So it's forwards. And then we're going to rotate it in the Z by the index multiplied by 10. That's it. And that goes into there. So it's rotating out and doing like a whole rotation around, looking around 360 degrees. And we're going to take that and add that to the player's location. And that'd be a start point of the line trace. So I'll do the line trace out, and you can do a capsule trace, sphere trace, whatever you want. So we'll do that, and we'll leave it at visibility. That's totally okay. And disconnect return node. And if that is a blocking hit, we're going to do a branch to check that it was a blocking hit. And then I'm going to break my out hit. And on there, we're going to have a location. We're going to store that location as part of our array here. So drag out your array, get context locations, and here we're going to go add there, put that to true, and we're going to add our location there. However, if it doesn't hit, we want it to return add our trace end. So we're going to take the branch. Oh no, we'll leave it like that. We'll leave it like that. So this is actually going to generate cover points basically. So that's going to add the location to the context location array. Then when it's completed that, you're going to come down here, and if you type in, I think it's generate. Yep. Oh, that's right. Yeah, you just drag out your array here, and then do a for each loop. So for each point that you've found, you're going to drag that and connect that to your completed. And from here, you're going to generate and do add generated vector. Plug that into there, and when you're done, you can do your return node on the completed here. And I think that was it. I think that's all you have to do to this. Get rid of that. Hit compile and save that. And this custom generation will do basically cover points, because it's going to look outside and trace in and see if it hits something. So I'm going to go into my find hiding spot, and we're going to change the generator here. Actually, no, we'll move this aside. We'll just disconnect that. We'll add a new generator here. And you'll see a custom generation appear in this list. Click on that. Hit save. If I go into here now and click on my testing pawn, if I can, let's do it here. There you go. Oh, I think I should forget. Hang on, before I forget. Make sure generate point. Yep, that's fine. Add cut generate vector. Yep, that's fine. That should be okay. Context square. Save. There may be just no points available. Hold on. Oh, I just realised I'm doing it with the player character, not the... Hang on. Again, I'm looking at the wrong thing. The reason why it's not working is because I'm looking at get player character, which isn't obviously running at this time. So we're going to plug in... Can I do context from here? No. Okay, it's fine. From that, we'll just go start here. Get actor location. Actor of class, sorry. Choose my third person. If you want to, you can keep it as the player character. But you just might be able to test it, that's all. Right, to variable. And we'll just plug that in down here. Compile and hit this. And we should get some points generating. Oh, has it crashed? I think it might have crashed. Custom generation does like to crash. There you go, it crashed. Okay, alright, whilst we're here then, we'll load up my other one. I'll show you it working when it's finished. Hold on. Yeah, custom generation, if you don't get it right, it will crash. It's a pain in the ass. So bear that in mind. But I'll load up working examples of it being used. Hold on. And I can explain how it works. Oh, I did have an error. Oh, I didn't see it, sorry. Yeah. Yeah. Custom gen. Well, if I leave it like that, you can. Yeah, it should be okay to leave it like that. If I generate around query, hit play. Do this. Do we see any points appear? No. Never mind. I'll show you the working example when it's completed because we're running out of time here. And I do take some questions. Okay, let me show you my ones that I made. So I've done a new cover system stuff. Where is that? Cover AI. And also got bot AI as well, which I'll show as well. I'm gonna close this project for now. Close that and close that. Yeah. Whilst that's loading all up, I'll take some questions, I guess. So questions we got from Red Chocobo. Do you watch tutorials to learn this stuff too? Or do you work at Unreal? Or how do you acquire knowledge of Unreal? I don't work at Unreal. Do I watch tutorials? Not really, no. The way I learn is just mucking about. I jump in, see what things do, how it breaks, and try and make sense of it. That's essentially how I do it. I've been teaching games development for about 10 years. I've been using Unreal for about 4. So I'm taking, yeah, just cracking on with it and just seeing how it works, see how things go together, just trying things out. I apply basic knowledge of programming obviously to a lot of things. So if I apply logic and reasoning and programming basics to it, I kind of get to the gist of it. Yeah, basically how I do it. Okay, here's an example of cover shooter stuff going on. So here they'll hide behind cover and duck and shoot. And they will also approach you. That's what I was working on. This is something I was working on, just trying out some stuff the other day. They will eventually start coming towards me, and like, there you go. And they'll run and hide. They see themselves exposed. Oh, you can't see nothing. Whoops, my bad. Always away. Hold on. There you go. So, oh, hang on. Let me escape. Push play again. Okay, so here is the cover AI stuff going on. So they hide behind cover, they find it. And if they see and exposed to it for too long, they'll try and run for another cover. And also, at the moment, their cover will be that always look for the furthest point until they want to approach you. So, like the one at the back, they just tried getting closer to me. It's just me mucking about the other day, trying to try some stuff out. Yeah. And so it's a lot simpler than my other cover shooter stuff I've done before. So if I show you the behavior tree for this, this is all it is. Just this. So I've got 2 query going on here. One for target cover, one for approaching the cover. But yeah, there you go. There's that one. So that's quite cool. Working more on that to get more realistic AI stuff going on to it. Can you upload this one to the Patreons? What, this exact file? Yeah, I probably will be doing it. I'll also be doing another AI series on this, I think, as well. People tend to want it on Twitter. So I asked on Twitter if people want to see this again. Reason being is because it's shooter AI cover again, but done differently. I don't know if people want to see that again. But yep, I can put it on there. It's totally fine. So it'll be up there for gold patrons, because gold patrons get project systems. So they get that. Okay, so the other one I've got here is Shooter Bots, which is a current series that's going on at the moment with Patreon members. Yep, Online King, I've got something similar to that in this video here. In this project here. What other questions? Any more other questions about EQS or AI in general? Is it possible to use Eqs to generate a mechanic like a random environment interaction in a system for NPC? It depends if you want just a it's just meant for locations. It's not going to spawn anything in. Well, I guess you could spawn something in, because if you want to say spawn like, I don't know, because you get a point out and you can put that into any task for absolutely anything. So yeah, in theory, yeah, you could use it for all sorts of things. Yeah. So here's like an AI based one. So he's using Eqs in here to run around the level in a natural way, and when he sees me, he'll start shooting at me. And I can kill him. So basic behavior. But he will just run around the environment in a semi-realistic way. And what I mean by that is he won't go zigzagging all over the place. He'll follow what's naturally in front of him. So he's not going to come down those stairs. Oh, you see me. Crap. There you go. So this is a series that's currently out on Patreon. These guys are getting this out at some point here. I'm going to add other stuff to him, so he'll bunny hop and zigzag around to try and dodge your shots. So we'll be looking at that, because we're going to use Eqs as well in here, and I'll show you how Eqs works in this, to tell which way the player's looking and filter out those points. So in here, you can see, if I push this off here, the way this works is I've set different context here for points. I set these sort of points of interest around the map. So I've got Eqs points of interest set up where I want the AI to try and focus their attention on. And I'll generate a grid at each of those points. Okay. And the way it works is whichever way it's facing, it'll prioritize those ones. So if I turn this thing around, it'll score those that are inside this radius, this bit here, this cone, higher than those to the side. And that's using dot. So that's a dot test for that. And that way it'll always aim for the one that's semi-closest in front of it. So he'll go in front of him as much as possible. If there's none in front of him, they'll just pick ones to the side because they'll be the next highest value. So you get this sort of realistic running around the map motion like you get in Call of Duty, rather than a zigzag all over the place. You get them just running around stuff. But that's a dot one, so I can show you that behavior here. So that's the behavior tree. So that's all his behavior tree is, by the way. That bot doing that. Really simple. The Eqs here, again, quite simple. Got a distance, and we've got a dot here, which is taking the rotation and looking at each item in the grid. Cheers, Online King. Yeah, there you go. There's that. And this should work for multiplayer as well. In theory, if I drag, if I do another player start here and do launch options, no, the shooting may not work for the AI, but he'll still run around the same way as he does in the other game. Oh, there he is. He may not see me because, again, I haven't coded it for him to look for you on the client. There's the other player. Oh, there you go. But yeah, we can work on AI later. But multiplayer later. Eqs feels a bit like the A-star system. It's not Eqs. The whole navigation system in Unreal is A-star. It's not Eqs. It is A-star, and you can see that if you go into if I go into the project settings here and turn on Nav Mesh segments, draw poly edges. So there are the individual grid patterns for the A-star, and you can see, if you know about A-star algorithm, it scores each one of these and works out the cost of running through it. Fun fact as well, I've also put in a Nav Mesh modifier in here. So what this does is I've made these points, this red point on the Nav Mesh, cost far less. So it's actually quite cheaper for him. If he wants to get from this side of the map to this side of the map, he'll prioritize this bridge here because it's a much cheaper way. So if I want the AI to sort of favor that, I can make them favor that by making this modifier, which modifies the cost of it a lot lower. But yeah, so you can see the cost there. You can actually see the costs of each one. So if I go into project settings again, go to Nav Mesh, you can see labels, polygon labels, and draw default polygon cost. So you can see the cost of each polygon. It's quite ridiculous. And these ones are set to 0.1, I think they are. 0.001. Whereas the green ones are set to 1. So it's going to favour the red part more so than others because it's going to work out a lot cheaper. Okay. But you can, I'll do another video at some point about Nav Mesh modifiers and what you can do with that. It's how you get an enemy to choose to run around a pond rather than go through the pond, and or unless it's a dire situation, you want to make them go through it. Make it if the seat is actually an actual shortcut, you favour it. Things like that. Any other questions we have about this, by the way? Episode 3 of this project, by the way, if you're a Patreon and watching this, episode 3 of this project will be out next week, which we actually cover this Nav Mesh modifier. And then after that will be the shooting one. Red Chocobo, are you able to make a fishing mechanic tutorial? I like the idea of doing it. I've added it to my list. I don't know when I'll get round to doing it. Maybe later this year when I go full-time. So if you don't know, I'm doing this now full-time from July. So from July, I'll be doing this channel, making videos and helping people one-to-one wise. I'm doing consulting work and project work for people from July. I'm currently still obviously doing one-to-ones all the time, and I'm doing project work all the time, like work for hire basically. But I'll be able to offer a lot more later on and do a lot more stuff and a lot more live streams, a lot more videos. Yeah, from summer. Cheers, Ian. Good to see you. Thank you. Thank you. It is a scary thing, but it's exciting. Okay, I think that's it really. So Eqs is one of those things that will take a bit of experimentation for yourself and a bit more lateral thinking. So definitely try it out, definitely check it out, and see if you make a basic hide and seek game. So that'll be my first task for you, is make a hide and seek game to test your skills with Eqs. And that'll do it for tonight. What you can look forward to this week coming up over on YouTube and on Patreon. On Patreon, you're looking at more of the RTS series, real-time strategy game, that is. We're on part 8 next week. And we are also working on part 3 of this one that you see in front of you. We're also looking at the next part in FPS RPG Chapter 6 as well. If you're not already part of Discord, you can join a Discord, Online King, free of charge. There's a general tab that everyone has access to. Patrons have access to further channels in it, like the show off channel, the bug fixing, and patron only rooms. But you can join it. Link is all in the description of this, as well as on my about page on my channel as well. on YouTube. You can look forward to the continuation of the jigsaw puzzle series coming out. You can look forward to more FPS RPG stuff. You can look forward to more stealth AI stuff as well. If you want the stealth AI project files, they're available to gold patrons on my Patreon. If you want the project files for the cover shooter stuff, I will upload it, I think, Asmund. So I will add that to the thing so you guys can have a play of it and see what you like from it, and rip it apart without me making a video on it just yet. So yeah, that would do for me. Obviously there is a live stream again on Wednesday for our question time, so if you have more questions you want to ask, you can bring them along on Wednesday for our online question time, where you can ask any question you like from 11 PM BST live here on my channel. Thank you everyone for watching. Have a great evening, a safe weekend, and I'll see you next time. Bye everyone.